Bismillahirrahmanirrahim. So we started the first introduction about network security. We talked about basic definitions, about what computer security is, what network security is, and we stopped here at the basic definitions for the difference between security attacks, security mechanisms, and security services. So we said that the security attack is any action that can compromise the security of information or any resource in any organization. Security mechanism is the technique that we can use to detect these security attacks or prevent or recover from any security attack. And then the service is the one that uses one or more of these techniques or mechanisms to provide security in a specific communication setting. So we talked about an example of HTTP and HTTPS. So HTTP is one of the very common protocols that people use for communication between a client web and a client, and a web server. And HTTP itself is not secure, but if we want to provide some security services like confidentiality, integrity, availability, all of the services that we talked about, then we use HTTPS, which combines some security services with HTTP as a baseline protocol to have secure communication. So security attacks can be classified into passive attacks and active attacks. So the passive attacks are usually done with the intention of active attacks. Okay, so passive attacks, they include the eavesdropping. So there is a communication between Alice and Bob. So you see Alice and Bob very commonly in all security textbooks, of course. And you have Darth or Eve that represents the adversary or the attacker. Okay? So passive attacks talks about the fact that if Alice and Bob are communicating anything, then Darth can come in the middle and just listen to the communication. So leak some information from the communication. Okay? So of course, the way to secure the communication against the passive attacks is simply by confidentiality, to provide some confidentiality, to try to prevent Darth from being able to leak any information while Alice and Bob are communicating. So this is what we call passive attack. Okay? So you're just listening to the communication. So it's like you have sender and receiver who are communicating, whether this communication is over wired or wireless network. And then you come in the middle and you try to get some information from here or here. Okay? Active attack is different. So if you want to, for example, manipulate the data, this is some kind of active attack. Okay? If you want to change the communication that is being communicated between Alice and Bob, this is what we refer to as active attack. And usually, that's your ultimate goal. Even if you are doing passive attack, is later on to, so like for example, if you want to listen to the communication in order to extract, for example, the password, okay, then use this password to get to the server and to have access, illegitimate access to the server in order to perform some manipulation to the server. If you want to get some credit card information, if you want to use that credit card to do further attacks and so on, okay. So usually the passive attack is done with the ultimate intention of doing active attack later on.
So what's the meaning of X800? Because we saw in Crypto
X800
X500.
is the standard specification or the specification document that is developed by ITU, in which they define these categories of attacks as passive attacks and active attacks. As we said, we talked about this last time, we said that we have some standard bodies, right? We have NIST, we have ITU, we have ISOC or IETF, right? So these are standard organizations that they try to develop some specifications that have to do with security techniques or security services.
So it's the standard?
Yes, so this is like a standard specification in which they define, it's like, a standard has to do with some techniques or services that people have to implement. Here we're talking about basic definitions, right? So we're not yet talking about actual technique or service, okay, that people have to implement, okay? So the standard focuses on specific techniques or services that people need to implement in order to have interoperability. So if I, like for example, TCP, if you and I implement TCP in the same way, even if you are, like for example, D-Link and I'm Cisco, our devices will talk together, right? Because we are talking the same standard. Here we're still talking about basic definitions, okay? So we'll try to talk about some specific examples for attacks in each of these categories, okay? Okay, so as we said, there are two types of passive attacks. They are the release of information content or traffic analysis. So by the release of a message content, we mean that we listen to the communication with the hope that hopefully you are communicating your password in a plain text, right? Or maybe you are using some security mechanisms, but you are sending a packet, right? You are sending a packet. This packet has a header and data, okay? In many security services, they try to encrypt the data, but not the header, because if you encrypt the header, the routers will not be able to read that header in order to perform their routing, their functionality, right? So in many security services, it's not common to encrypt the header, okay? So now the attacker can get this as an advantage to read the content of the header because it's plain text, right? I can read this and extract some information out of it, right? So that's what we mean by releasing the message content. So you listen, you do some passive attack with the hope that either you're not using any security techniques or you're not encrypting the whole thing, okay? Traffic analysis is different. Traffic analysis, even if everything is secure, right? You try to read thousands or hundreds of these messages, okay? And then every time, what you do is to try to guess how this message was encrypted, okay? And of course, encryption, as you have possibly or supposedly studied in applied cryptography, the encryption is based on the key, because the encryption technique itself is published, is there. We know the encryption technique. What we don't know is the key. So traffic analysis tries to guess the key. You try to guess the key. You try different keys, different key combinations, okay? And then every time you try to decrypt the message using that key. And you have to have certain assumption on the content of the message. Like, for example, the content eventually is in English, for example. So if I use the key and decrypt this message, and the decrypted text looks like a proper English language, then what did you do now? You have broken the communication, right? But in order for you to do this, you have to try possibly thousands of these keys, right? So this is what we mean by traffic analysis. So in that case, just reading the message is not enough. You have to read the message and perform certain function, okay, by trying thousands of these keys, and every time you try to see whether the decrypted text looks proper English or looks like a proper message or not, okay? If it looks like proper message, then you have successfully attacked the communication, or you have performed a successful passive attack for that communication. So that now you have the key, you can now use that key to read more messages, okay? And then later on, you can from these messages, you can get more and more information and then use this information later on. So I can decrypt your password, I can decrypt your credit card information, I can decrypt many things, and then use this information later on to perform active attacks. Okay? واضح كده؟ So traffic analysis is not merely reading the message content. You have to read the message, you have to try to decrypt it, and you have to use different combinations of these keys until you are successfully the content of this message. So these are the two types for passive attacks. For active attacks, there are multiple types. So there is Masquerade. Masquerade here represents impersonation. Okay? Impersonation. So now you have, there is a sender, there is a receiver, okay? And for some period of time, you have been able to do some passive attack, and you have read some information. Now from this information, you can try to do the following. You can say, oh, okay, so now I will put myself in the middle of the communication. So the sender will think I'm the receiver, and the receiver will think I'm the sender. So this is what they call a impersonation attack. Okay? Impersonation attack. So the sender sends to a specific IP address. I will intercept this communication, okay, and respond back to the sender as if I have this IP address, although I don't have this IP address. Okay? When the receiver tries to send back to the sender, I will also intercept this and say, okay, now I know what you are trying to send me. I will send you back some confirmation. So now the sender thinks that I'm the receiver, and the receiver thinks that I'm the sender. So this is what we refer to as masquerade or impersonation attack. So that's definitely active attack. So it's not merely a passive listening. So I have to send you something to convince you that indeed I'm the receiver, indeed I'm the sender. Okay? And you have no way to verify except if you use certain security mechanisms, which we will talk about.
Is it similar to stealing the session cookies?
The session?
Cookies? Like you are the person when you have the session cookies. You are the person. So is it similar? Because here it says when one entity pretends to be a different entity.
Yes, when one entity pretends to be a different entity. If the cookie allows you to get some information and later on send back some confirmation that you are indeed that person, then yes, what you're saying is true.
Because if you have the session cookie, you can log into the user account.
Yes, then it is what we're talking about here.
Is it similar to man-in-the-middle attack?
Yes, it is definitely man-in-the-middle attack. This is what they refer to as man-in-the-middle attack. Okay, so impersonation is in fact man-in-the-middle attack. Replay attack is actually kind of interesting, because you're not actually doing some impersonation, and you're not reading the message content, and you're not updating or manipulating the message content in any way. All what you're doing is basically to take a message and later on play it again. That's it. By doing this, you corrupt the communication. Okay? So if you are sending some packets, okay? So if you're sending these packets as a sequence, so these packets could be like a content of a video file, for example. Okay? If I succeed here as Darth to take one of these messages, okay, and then later on send it again, the file content has changed, right? I take the same, it's encrypted. The message is encrypted in that case. I did not manipulate the packet in any way, okay? All I did is just to send it the same packet again, which is encrypted, but send it again. So your protocol should have a way to prevent me from doing this, okay? If not, then using this replay attack, I will corrupt the communication, right? A very famous example for replay attacks is people use it actually to steal cars. Because all the keyless cars, what they do is that your key, in fact, sends some authentication message to the car, which allows you to open the door, as long as your key is close to the car. And the key, in fact, sends some secure message, okay, to tell the car that, indeed, I am the proper owner of this car, okay? So the owner can open the door, right? So it's very famous way to steal the cars that while you are walking in the mall, someone can, because the key sends this message as a broadcast message in a regular frequency, okay? The key has to do this. So I come closer to you and then I try to capture this message, this same message, okay, and send it with high power to someone else close to the car, okay. So this guy can relay the message as is to the car and open the door, okay. So this has been one of the famous ways to steal cars at some point.
In this case, it's not to corrupt the system.
It's not to corrupt, yes, but the replay attack has different ways to attack, right? One of them is to corrupt a content of a big file, because any file is a sequence of certain messages or packets, okay? So if you try to repeat the small content of this, you corrupted the whole thing. It's like a zip file or something, okay? Another way is to use it to replay a message, like simple protocols like keyless cars. They use simple protocols to just send authentication message to the car. So I can just relay this message in a later time. Of course, now they fix this. They have mechanisms to fix all these issues. Okay, but these are examples for how you use the replay attack to attack certain communication. If you guess, what is a simple way to mitigate this? Mm-hmm.
Have a key pair between the
لا the key we know. لا احنا what we're saying here كنتش موجود. What we're saying here is that we're taking the same message which is encrypted and we are replaying the same message again. So it's still encrypted with the key. I didn't have to know the key.
We use like nonce, right? We can use nonce.
Bravo, Alec, yes.
Yeah.
Use nonce, use sequence numbers. Right. So these are the things that... so these nonce are random numbers which they get generated regularly. So if you try to replay the same message again, okay, every time you need to have a different random number. It's like a sequence number, okay? So if you send the same message again, then I will say, no, this is not a new message. It's the same message that was sent a few minutes ago, okay? Because it has the same content and the same. So every message that is being sent should have like some unique ID. It's like a sequence number, or sometimes they call it nonce, to verify that it's innovative message. It's a new message. Every time it's a new message. But again, this is a security mechanism that we have to do to mitigate the replay attack. Type. Modification of messages, we talked about this. اللي هي to affect message integrity. Okay? So I come in the middle of the message and then I insert something. So that's an active attack. Okay? Or bad denial of service attack. Denial of service attack is one of the very, very, very tricky attacks that many people they use. It requires huge amount of resources, right? So if I want to attack a certain server, and this happens here many, many times, supposedly you get millions of requests from different locations to the server. Have you tried the example that we talked about last time? The DDoS map. If you search on Google DDoS world map, there are many websites that gives you the entire map of Earth, and it gives you in real time the DDoS attacks that happens from one location to another, in real time. And you see that one location is getting thousands of requests from different locations. And in order for attackers to do this, what they do is that first, they manage to gain access to any idle laptops or phones or something like this, okay, which are idle usually during overtime periods or something like this, okay? Once they get access to your laptop or mobile device, then they launch requests from your device to the server. Because sometimes DDoS attacks can, if you use the same machine to send millions of requests to the server, that's easily detectable because I can easily detect this. I get thousands of requests in a short time period from the same client. I can just stop this, okay? But if you're getting this from thousands of machines, you have no way to figure out what's going on. And in that case, many devices, many of the servers, they can really fall into that trap of denial of service. It happened even to Facebook, WhatsApp, Google. That's why we talked about the concept of availability, right? Availability is the security objective or the security service that we need to have in order to mitigate denial of service. We need to make sure that our server is available, hopefully, 24/7, even under the DDoS attack. Okay?
This way, sometimes they have like a timer. You can do it again after 60 seconds.
Yes, so yeah, but the DDoS is based on the fact that within these 30 seconds you have thousands of. So this is the way you bring any server down. But if you have a request every 30 seconds, the server can cope with this, right? Server can cope with this easily. Okay, especially illegitimate requests. Okay, so these are 4 types of. So we talked about 2 types for the passive attacks and 4 types for the active attacks. So these are the security mechanisms that you should have covered, some of them at least, in the previous course, Applied Cryptography. And these mechanisms, we can actually divide them into 2 categories. These mechanisms are layer specific, okay, or protocol specific. So we can perform these techniques in a specific network layer, in one network layer. These techniques they call them pervasive security techniques, agnostic to the layers. They don't have anything to do with a specific layer. They can be performed anywhere, okay? We don't have to understand all the details about these, although you should have covered many of these in applied cryptography. But we'll go through them very quickly, okay? Of course, encipherment is easy. Encipherment or encryption, okay, is easy. It's used for confidentiality. So you provide information concealment, right, using an encryption algorithm and a key. The key is very important. The key is the most important, not the algorithm, because the encryption algorithm itself is available, it's published, okay? But the key is the most important thing. Digital signature is a way to ensure the integrity. So digital signatures is the way to ensure data integrity, like similar to our signature in the bank. So if the bank, they have your signature, and they verify that your signature is really authentic and is coming from you, then they perform the transaction. Because on one hand, this means that you approve the content of this transaction fully, okay? The content of this transaction have not been manipulated or modified or anything, okay? And in some cases also, digital signatures are used for what else? For non-repudiation, right? So if later on you say, I did not perform this function. Then we say, no, you did it. Your signature is on the official document. So you cannot later on deny and say, I did not perform this transaction or this transaction or this. اللي هي accountability. برافو عليك. Yes. Okay. So we'll talk about these mechanisms in the next chapter again quickly, because I assume you have covered this. It looks like you did not cover but we will go through them quickly يعني in the next chapter. Yeah. But يعني we have to do it quickly because this is not the main topic of the course, right? Access control, يعني maybe you did not cover this, but access control really talks about the different privileges on a specific system. So if you enter the system using your user ID and password, these credentials, they give you a certain level of access to the server. Okay, so a certain database you can access, but not specific table. You can access the files, مثلا as read only but not write. You can modify the files, you cannot modify the files. You have, for example, a normal user access versus an administrator access and so on. So you have access lists and you have revocation lists and so on. So this is what we call by access control. This has nothing to do يعني direct relation with network security per se, but this is to secure a specific server. يعني. Data integrity, of course, we talked about it. Data integrity sometimes requires digital signatures in addition to something else, or in addition to some encryption. So it requires actually digital signature and encryption at the same time. We'll talk about this in the next chapter. There is authentication exchange. By authentication exchange is different from authentication اللي هو user ID and password. There is user authentication and there is communication authentication. Okay? User authentication is what you use in terms of login, user ID and password to gain access to the server, right? Authentication exchange here, it means that we need to tell each other that we are really the authorized person to communicate. Okay? So authentication exchange happens during the communication between two entities. Okay? So when I receive a message, I need to make sure that I'm receiving this message from Muhammad and not from anyone else. Why? To prevent impersonation attack or man-in-the-middle attack, right? So if the message is coming from you, okay, and I don't have a way to verify that this is indeed you, okay, then it might be coming from someone else who's impersonating you. You see what I mean? So this is here authentication exchange is to avoid man-in-the-middle attack, basically. Okay, and for that they use what they call message authentication codes. Okay, so if I assume that there is a sender and there is a receiver here, so the sender sends the message, the data, okay, and in addition to that, they send what they call message authentication codes. These message authentication codes, they do two things. They have the digital signature to make sure that this data is not altered, okay, and they also have a key, okay, not the key itself. They also have a message encrypted with the key, and this key is owned by me only, okay? And in order for you to verify that this is indeed me, what you do is that you decrypt this message using the same key to make sure that the message is coming from me and not from anyone else. So MAC is used again to prevent man-in-the-middle attack, okay? But this is different from the encryption that happens to the data itself. So sometimes we use two keys actually. We use key 1 for confidentiality, and we use key 2 for authentication exchange. Okay? And we have multiple keys. Generally in the communication, we have more than one key. So one key is not enough. So you have one key for encryption and one key for authentication exchange.
Is it like the master key and the session key?
Well, we can use public cryptography or we can use symmetric cryptography for message authentication. We'll talk about this in the next chapter. So if I use public cryptography, okay, then what I do is that I use the public key, okay, to decrypt this message and get the original content, okay? But to authenticate you, I have to use my private key to decrypt the MAC and get the text. So usually, if you are using public cryptography, then you can, in fact, because public cryptography is based on two keys, right? Private key and public key, okay? So public key, okay, is used to encrypt message that gets sent to a particular person, okay? But the private key is used for authentication or message authentication codes. We'll talk about this in details in the next chapter again, okay? But in any case, authentication exchange has authentication in general has two levels. There is user authentication and communication authentication, okay? User authentication basically done by a username and password, and that's it. So you authenticate yourself to the system. This is indeed me, and then you gain access to the server, right? But this is not enough when you have two entities communicating. When you have two entities communicating, every single message has to mark your identity. Otherwise, I can have man-in-the-middle attack, and someone comes in the middle here. Darth comes in the middle here, okay, and tells the sender, I'm in fact the receiver, tells the receiver, I'm in fact the sender, and talk to both of them, and both of them will not be able to verify that this is the other entity, okay? So to avoid this, and in order for Darth to be able to do the impersonation attack, Darth has to have the key for the MAC or the message authentication code, okay? So if Darth does not have this key, then Darth cannot really impersonate the sender or the receiver. طيب. Traffic padding we will not cover this in details, but traffic padding basically what it means is that if I send you a packet with the same size, okay, with the same size every time, okay, what does this tell you? This tells you that the message size is X type. What is the problem with this? Some attackers, they use this for their benefit to do traffic analysis. We talked about the traffic analysis, right? We said that we have an encrypted message. We can take this message and we can try different combinations of the key to try to decrypt the message, right? So this is done during the traffic analysis. It turns out that if this message size is fixed every time, this will simplify my job. Okay? This will make my life easier. As an attacker, this will make my life easier, right? So if every time I'm expecting the message to have the same size, then that's easy. I can use this for my benefit, okay? So traffic padding is a mechanism to try to add some dummy content to the message so that every time the message has a different size. Okay? So it's like to add dummy bits, okay? And then in the protocol, of course, after you decrypt the message, as part of the header here, you have the length of the actual message without the padding. So if the receiver was able to decrypt the message correctly, the receiver will be able to know the actual size and ignore the padding. But the attacker will get the message encrypted with the padding, right? So he will be totally confused. he will not get any fixed size, so his life will be much harder. So they use traffic padding to confuse the traffic analysis, to make the traffic analysis more complex. So you have to spend more effort and more resources in order to be able to guess the key and attack the communication. Okay? Because if the message has a fixed size, then this gives you an indication that the key has fixed size, so you know the key length, so you can try to guess and break the communication. If you have traffic padding, this will confuse you completely. Okay? So they use traffic padding for this. Type. Routing control. So in network 1, we know routing, right? How do we select the route between any two entities across the network? We try to estimate the best route using Dijkstra algorithm or using any kind of, that's easy, right? So imagine if I say, okay, so you have two entities and you have a specific network and this is the route, okay? So if the message is going from the sender to the receiver across this route every time, what does this tell you? Again, as an attacker, you can tamper this communication easily, right? Okay? So another way to confuse the attacker is to say, I will send the messages. I have some messages, right? But if I can send these messages through different routes, okay, so the attacker will be confused even more, right? So routing control here talks about the fact that I will send the messages across different routes to try to confuse the attacker, but this will mean that some of these routes might not be the best route, right, in terms of cost, and which is the default best route that we have learned in network 1, okay? So now my routing protocol has some security considerations. It's not necessarily the best route that I'm going to select at this point of time. I will have a different strategy. I will select the best route or suboptimal route that's based on enhancing the security. So I will send the packets through different routes at different days, at different times of the day to confuse the attacker. So now in order to confuse the attacker, we are sending packets with different sizes, okay, with message authentication codes to make sure that message is coming from an authorized or authenticated source, and sent through different routes to confuse the attacker even more. So all of these factors, it makes the attack harder and harder, okay? Notarization here talks about the fact that if you send me message authentication codes, sometimes instead of message authentication codes, they use certificates. We have all heard the certificates, right? So these certificates, they contain the key inside them, okay? The public key, not the private key, of course. Private key is not for sharing, right? Yeah. The public key is for sharing, right? So I'm sending my public key. So I'm telling others, this is my public key. If I'm telling you, this is my public key, would you believe me? Maybe yes, maybe no, right? Because maybe I'm an attacker, and later on I can allow you to use this public key, and then I impersonate and I get some information from you, right? So this is similar to if you want to buy مثلا a house in the US ولا حاجة زي كده, then you tell the person, oh, okay, here, this is my identity and this is my information, okay, so now I'm the owner, okay? I don't believe you, okay? So this has to be through an entity that we both trust, okay? Here comes the notarization. Notarization talks about certificate authority. So if your certificate is trusted by a certificate authority, only then I can believe you. Okay? So if I'm telling you this is my public key, you don't believe me. But if this is notarized by my, like for example, Microsoft certificate authority, which happens through your operating system, communicates with Microsoft, and Microsoft automatically notarizes your public key, okay, then and only then you can trust it. So now the certificate is not coming from me. It's coming from Microsoft Certificate Authority. This, in fact, happens in the back scene whenever you try to communicate with any server using HTTPS. So whenever you try to connect to any server using HTTPS, what happens is that in the back scene, Windows generates a public key and then notarizes this through the Microsoft Certificate Authority, and then it communicates to the server to notarize this server that indeed this is my public key. So then and only then, the web server can use this public key to encrypt messages to send it to. Okay? They trust this certificate. So this is what we mean by notarization. Okay? So all these techniques, they work hand in hand. Again, we don't have to use all these techniques depending on the security service that you want to have, right? In addition to these, you have some pervasive security mechanisms, as we see here, like event detection. We talked about event detection, security trusted. Sorry, the security label which you added to a specific file on the operating system. So this has nothing to do with communication. In that case, this has nothing to do with communication. This is implemented in a specific server. It has nothing to do with a specific layer or a specific communication. Event detection is, as we said, like if there is any intrusion, then you can look to the audit files, and then based on that you can trigger a certain event. This event is like there is a possibility of security breach, in which case you need to take certain action, you need to secure your system even more, and so on. So again, this has nothing to do with the communication or a specific layer of communication. This is what we call pervasive mechanism. Okay? So this is usually based on what we call so this is through the security audit trail, which is like some audit logs, and sometimes, by the way, the security audit logs are different from the system audit logs. Sometimes it's the same, sometimes it's different. Okay? So when you record some audit records for security is different from the normal system audit logs. Okay? Usually. Okay? From these audit logs or audit entries, you can, like for example, you can use machine learning. If you have these audit trails with a specific form or with specific data, this might tell you that there is some kind of possible intrusion to the system. Okay? Or potential intrusion of some sort. Then you have to make your security techniques tighter and tighter. Okay? And that's why there are security levels. So we can combine a subset of these mechanisms at different times to make a security level very, very secure or less secure or no security at all, right? Based on that, based on certain event, you may want to raise your security level of the system because you see that there is some suspicious behavior and there might be some security breach, in which case you need to raise your security level even higher. Okay? And security recovery, of course, is based on the fact that when you detect the event of security, when you detect any security event, so now you are sure that there is some kind of attack or intrusion happens to the system. So how do you recover from that? Okay? So there are also some techniques and mechanisms that allow you to recover from this attack. Okay? Like for example, you know that there is some password has been breached or stolen. Okay? Then in that case, you reset all the passwords and you force the user when he logs on, or some event that you detect that some keys or some certificates have been stolen. In that case, they do what they call a certificate revocation. So you revoke all the certificates that have been breached and force the users to renew these certificates and create new certificates and so on. Okay? So this is what we mean by security recovery. Okay? You don't have to know all the details about this, because actually going through this mechanisms requires very, very long time and possibly a course on itself. You may not have covered all these mechanisms in the applied cryptography. Obviously, you did not. But this is just to give you some idea that there are many, many of these mechanisms that usually they have to work hand in hand. Okay? And in some cases, you use a combination or subset of these security mechanisms to raise your security level at different levels in the system. Okay? And again, this is all a part of X800 certification. Security services is what we will cover in this course in details. And the security services is a processing or communication service provided by a system to give a specific kind of protection to the resources. Okay? So the very famous example that we've been using is HTTP and HTTPS. So HTTPS is nothing but HTTP plus some security services, right? Which needs to fulfill confidentiality, integrity, availability, authentication, and so on. Okay? So if you combine all these security services with HTTP, then you have HTTPS. Okay? So in the course, what we will do is that we will go from the network access layer. So we'll talk about network access layer. What are the security services in network access layer? How do we do this network security services in the network access layer? For example, if you want to secure your cable, your Ethernet cable, or wireless connection. Wireless talks about logical port. Cables talk about physical ports. Okay? So you may, in fact, get your laptop and try to hook to one of these cables here, and you see your laptop doesn't work. Why? Because your machine cannot authenticate itself to the Ethernet network of the university. Okay? So this is network access, okay, security service. So you connect physically and everything is fine, but you cannot fulfill the security service in the network access layer. Then we talk about security service in network layer. In the network layer, we have the most famous one is IPsec. IP security. So we studied IP. We know what IP is. We know the protocol header. We know everything. So now, how do we add security services to IP to make it secure? Because IP itself does not have any security. Okay? Then we go up to transport layer. Transport layer, we talk about TLS or SSL. Okay? So SSL is a security service that works in between TCP and application layer. Okay? To try to provide some security services. Okay? So that's what we are to discuss in this course. Type. Attack service here consists of a reachable or exploitable vulnerability in the system. And this doesn't mean that if you want to have a perfectly secure system that you do not have any attack service. You can't. Yeah. You cannot have a system without attack surface. You have to. Like, if you want to have a system with no attack surface, then this system will not be accessible by any means. Okay? Like, for example, مثلا HTTP port 80. Can anyone close that port for HTTP? You can't. And if you leave it open, that's an attack surface. Attack surface here talks about any open ports, okay, or a service available like HTTP. Can you just turn off HTTP altogether? You can't. Okay? This means that your servers will not be accessible from anywhere. Or a code, okay? Sometimes you can have like some JavaScript. So if you connect to Google or any web server and say display source, you see the JavaScript code. It's not encrypted. You can see it. But that's an attack surface. Okay? So you can use that. You can use that to attack the system. Okay? So you cannot have a system without attack surface. Okay? Interfaces, whether logical or physical. SQL or web forms. Sometimes these web forms are attack surface. I can write some data to confuse you or to perform certain active attack on a server. Write certain combination of data that I know for a fact that this might actually cause some corruption or some damage to the server. That's why there is a very big issue for QR codes. I mean, sometimes QR codes, and they don't know what you're reading. In QR codes, you can read something, and you read huge amount of data in a matter of a second, and you don't know what you're reading. Maybe what you're reading takes you to a web server, or you read a data that can damage your device, and you don't know. Okay, so logic or technically you cannot have a system without attack surface. Okay.
So is the goal to minimize these attacks?
Yes. So the idea is to minimize it, but not to eliminate. And this is a philosophical issue. Why? Because in some cases, personally, since I came here, I'm in constant, conflicts with ITS, because sometimes you understand that security is by closing doors and windows in front of people. Okay. So we need to access this. No, it's closed. You need to now. You have to use VPN. This VPN from inside the university. How come I'm inside the private network? So sometimes people understand security that we need to close everything in front of people. Okay, and some people they think that okay, so life is good. We leave everything open. Okay, it's neither. It's neither, actually, and that's why we need experts in this security area, because you have to have some wisdom to really open attack surfaces that you need, but also not to compromise the convenience of people. It's not that to avoid attacks, okay, is to make all types of inconvenience to the people who are using the system legitimately. But in order to do this, بصراحة برضو it's a double job, because also people need to be aware. So you need to raise the awareness of people that you need to be vigilant to use the proper ways to access the system. Like the very famous example that we talked about, people are now posting their احتراز on social media. So I can read your identity and read all the data about you just by pointing the camera. I can read everything. This is a big issue. People, they do this naively with lack of awareness, but other people can abuse this.
So the QR code directs you to something that...
مش directly. I can know everything about you. I can know your name. I can know many things about you just by reading the QR code. And I can do this easily. Now, like, you can point the camera and you can read the QR codes. Okay? So sometimes people, they do this out of lack of awareness, but they can cause some damage. Okay? You don't know what's in this QR codes. Maybe there is some password or your health number or some information about you that some people may actually abuse. Okay? So these attack surfaces, they can be categorized as network attack surface, like, as we said, like port numbers or something. Software attack surface, like so if we can categorize this, these two, they can be categorized as network. Okay? So any service or ports are a network attack service. Okay? So if we were to categorize for software, this is A, clearly, or this one. These two can be categorized as software attack service. Or human attack. The human attack اللي احنا بنقوله بقى اللي هو an employee with access to sensitive information, okay? And they expose this sensitive information either on purpose or out of naivety. They don't know.
The
Human is the weakest link. Yes, usually فعلا يعني human is the weakest link. يعني as a very simple example, you are using the most secure techniques and mechanisms and the biggest keys and so on, okay? But someone exposed his password. خلاص يعني هتعملوا ايه؟ What can you do? You can, any attacker can use this password to gain access, legitimate access to a server or to the network, okay, and damage the entire thing because of you. Regardless of all the security and that's why we have that accountability, because this is the last line of defense. Okay? The last line of defense is that just the fact that we do all these security mechanisms doesn't mean that our system is perfect. And we will always have attacks. Always have attacks. But accountability talks about the fact that if the attack happens, at least I can trace it back to the person. Okay?
And also that's why one of the countermeasures is like education, right?
Yes.
So that people don't give away.
Yes, true. At some point, I was discussing very interestingly. At some point, يعني I was starting to work on security really, and I talked to the people in HMC. So I told them, like you have all these healthcare services and stuff like that, but we need to make them secure. We need to make sure that privacy and all of this is preserved and so on. So the guy told me, you know what? We have done all types of education about security to the employees, and later on we discovered that maybe 60% of the employees, they still have password 1, 2, 3, 4, 5, 6. So it's a done deal. What can you do? So human attack surface really is the weakest link. Yes, I totally agree with this. It's a big issue really. Okay. So the last thing here is to talk about network models. Network models allow us to visualize a specific scenario in which we use services and mechanisms. Okay? It allows us to visualize a specific scenario. So if a sender wants to talk to a recipient, we can use this network model to allow anyone to visualize what we need to do to secure this communication between a sender and a receiver. So this is a model for network security to facilitate communication between sender and receiver. Okay? So to do this, we need to have security related to transformation. Like we need to make sure that we have integrity. We need to make sure that the data is protected from being transformed or modified, right? So we need to have integrity. We need to have some trusted authority, which is what we talked about, okay? Certificate authority, for example, to notarize that indeed I'm Amr, you are Muhammad, you are Manduh, and so on, okay? So to exchange public keys in a form of security, you need some third party. So for security services, in many ways, it's not enough to just have a sender and a receiver. You always have to have a third party. Okay? This third party, in many ways, it's used to distribute keys. مثلا, if we use the same key as the sender and the receiver, then we need to have a trusted authority that when I receive this key from this trusted authority, I know that this is trusted, right? So in many ways, security requires always a third party that comes in the middle to notarize the communication, to exchange or to distribute keys, and so on. We'll talk about that in the first chapter for security services when we talk about Kerberos, or one of the application layer protocols that's used to distribute keys. And we'll talk about this. Okay. Then we need to make sure that the information itself is concealed using encryption and so on. And so on. So this is to secure a communication between. This one here, we will study it in every single layer. Okay, every single layer, we need to do this communication secure, and we need to use different service levels and different mechanisms to secure this communication. Okay. So this is another security model to visualize a scenario where you want to detect intrusions. Okay? So the communication model, or this one, we talk about the network model or the security model for intrusion detection. Like, for example, this could be a firewall. So this scenario allows us to visualize how really the firewall works. So we have opponents who are trying to access the resources of the system, okay? But we have some gatekeeper, okay, who tries to make sure that whatever access is happening, that this is not with the purpose of performing active attack to the system or intrusion to the system, okay? So this gatekeeper works to make sure that this access is legitimate and it's not with the purpose of doing any kind of intrusion to the system. Okay? So this is what we call firewalls or intrusion detection system. Okay? So in order for this gatekeeper to perform this function, sometimes they need machine learning, because I need to make sure that your access is legitimate. In some cases, I need to monitor even your behavior. So maybe I allow you to access the system, but I monitor your behavior, and then I say, okay, so you tried to access some files that you shouldn't access and so on. So this means that maybe this is fishy. So in that case, I block you or something like this. Okay, or at least I record, and if the attack is complete, then I can trace it back to you and so on. Okay, so this is what we refer to as security models. So security models are a way for us to visualize a scenario in which multiple services and mechanisms they can work to achieve this security service. ماشي? And we have, these are the most famous two, اللي هو communication and the network access security model. So we have the communication security model and the network access security models. Those are the most famous ones. Okay? So that's